Hi guys, welcome to another one of RT Dowlett lectures, and today I will be looking at series and parallel circuits, and I will be looking at the basic theory. So this is the first video, right? So when we talk about a series circuit, there are certain characteristics that come into play, and the first thing is that there is only one path that the charges can take to complete a loop around the circuit. So one way they can go from the positive all the way to the negative. So when I talk about a series circuit, I am talking about having the current being the same. I am talking about the current I being the same at any point in the circuit. I'm also talking about having the voltage splitting up. So the voltage splits and the circuit is what we term a potential divider circuit. So one of the main things you have to understand is that the current is the same but the voltage is different. And to determine the total resistance, it is the sum of the individual resistances in the circuit. So let's go. So here I have my typical series arrangement, and I have three resistors connected one after the other. So I call this R1, I call this R2, and I call this R3. So the current is the same at any point in the circuit. So here my voltage will separate. So you're probably wondering, well, why? Because if I have different resistances, I need different values or different quantities of energy in order for my charges to move across each of the resistances. So you're using now V is equal to IR. Okay? So here, you're assuming that they are ohmic conductors. So we're going to say the total voltage of the battery is V1 plus V2 plus V3. So therefore, right, so V is ITRT, the total current by the total resistance, and that is equal to IR1 plus IR2 plus IR3. Now if you divide by I, because I is the same, RT is R1 plus R2 plus R3. Now if you wanted to get V1, because the current I is the same, you just multiply it by R1. In the same way, if you wanted to get V2, it is I by R2. And the same way, if you wanted to get V3, because the current is the same, it is I by R3. Another way is that you could say the potential difference splits as a ratio of the resistance. So you could take R1 over RT, the total resistance, and multiply it by the total voltage, right? Which is this. This is VT. And you can get what V1 is. V2 is R2 over RT multiplied by VT. And then here, you can get V3 being R3 over RT multiplied by V. Okay, so let us do an example. So let's say I have a 12-volt battery. I have a 1 ohm, 2 ohm, and 3 ohm resistor. I want to get the current through each. Right? So let's see how I could work it out. So I could say RT, you just add up all three, which would give me 6 ohms. To get I, it is V over RT, which is 12 over 6, which is 2 amps. If I wanted to get V1, it is IR1, so that's 2 by 1, which is 2 volts, V2 is IR2, which is 2 by 2, which is 4 volts. V3 is IR3, which is 2 by 3, which is 6 volts. And if I add all of these, I can get 12. Alternatively, I could say V1 is 1 over 6 multiplied by 12, which would have given me the same thing, 2. V2 was 2 over 6 by 12, which would have given me 4. And V3 is 3 over 6 by 12, which would have given me 6 volts. Okay, so let's look at parallel circuits. So a parallel circuit is where you have multiple paths for the current to flow. So you have V, then you have R1, then you have R2, then you have R3. Now, because the connections, this is the positive and negative, are such that you are connecting wires across the battery, the potential difference across the branch is the same. So the potential difference across here is the same as the potential difference across here, as the potential difference across here, and here as V. Now the current I will split through each branch because the charges now have 3 ways in which they can travel. So for parallel circuits, the voltage across the branch is the same, but the current splits. So the current across each is different. So what you will find here is that you can determine I1, which is V over R1, I2, which is V over R2, and I3, which is V over R3. So the total current will be I1 plus I2 plus I3, which is V over RT, which is V over R1 plus V over R2 plus V over R3. If you divide by V, you get 1 over RT is 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so let's look at an example now. So here, let's go back with the same scenario of a 12 volt battery, 1 ohm, 2 ohm, 3 ohm. So you have I1, I2, I3, right? So 1 on the total resistance is 1 over R1 plus 1 over R2 plus 1 over R3. I normally like to start with these questions, and most of the time the question is brought in that way, where they ask you to get the total resistance, right? So 1 over RT is 1 over 1 plus 1 over 2 plus 1 over 3. Find LCM. So that's 6 plus 3 plus 2, which is 11 over 6. So therefore RT is 6 over 11 ohms. So I1 is V over R1, I2 is V over R2, and I3 is V over R3. So I1 is 12 over 1, which is 12 amps. I2 is 12 over 2, which is 6 amps. And I3 is 12 over 3, which is 4 amps. So when you add it up, the total current is 12 plus 6 plus 4, which is 22 amps. Alternatively, I can get the total current by saying the total voltage over the total resistance. So that was 12 divided by 6 over 11. So that's 12 multiplied by 11 over 6, which would have given me 22 amps.